My name is Gregory Grabowski. I'm an MD. I'm trained as a pediatrician, a medical geneticist with subspecialty areas in biochemical genetics, molecular genetics, and clinical genetics. I specialize in the area of lysosomal diseases, particular Gaucher and lysosomal acid lipase deficiency. I've created therapies for both of them, which in the latter case of lysosomal acid lipase is life-saving. It's amazing that it's approved worldwide now. I've been in academia for almost 45 years, and in 2014 I decided I had enough and I went into a private company called Synergiva, and that's where we finished the development of the lysosomal acid lipase therapy. I'm now doing private consulting with a variety of biochemical, biomedical, biopharmaceutical companies on rare diseases of various types. A lot of interest in Gaucher, particularly because of its relationship to Parkinson's disease. And so there are a lot of big companies now interested in this, plus little ones, and multiple different approaches to developing therapies, whether it's gene therapy or CRISPR approaches or, shall we say, chaperones. And so it's a lot of interest in this area to try and fix these diseases. And the still untouched area in these rare disorders, whether it's lysosomal or others, is the brain. And this is a very important aspect for the kids, but also it relates to Parkinson's disease too, and some other neurodegenerative diseases like Lewy body disease. So it's a lot of different kinds of things, and I help evaluate different approaches. And then physicians and patients still call me and have questions about, a research project or the care of a patient or what's being seen in a patient during therapy, or whether their child should have this therapy or that therapy. And I always try to work in conjunction with the primary physician who's involved with this, so the families don't get mixed messages, and bring the truth to them as much as there can be. And they need to hear that. And sometimes it's not so good, sometimes it's very good, but it's so that they don't get confused and caught up in misinformation. So that's what I do. That's what I like to do. The section this morning was related to epigenomics and epigenetics. And what does that mean? And what is this? The question here is, in any of these diseases, whether they're lysosomal or other kinds of inherited diseases where we know the cause, and let's say you have siblings and even twins, identical twins in quotes, that have the same mutations but yet have very, very different physical, clinical parameters and presentation. And the question is, why is that? And the answer is, it has to do with modifications of genes and modifications of genomics, meaning a lot of different genes that these people have that are different. And even in identical twins, you can have different modifications. And so they should be called monozygotic, meaning they come from one egg, fertilized egg, and then they split and they can change differently. Now, it doesn't happen greatly all the time, but it does happen, and it becomes confusing. And then when you have twins or just different siblings, they have different genetic backgrounds, but then they have different genomic backgrounds. The genes that they get from their parents are scrambled in different ways, and then they're modified by what happens to them during development and growth in the uterus and so forth. So that's what was about this morning, and how that can be attacked. And we heard about some of AI coming in and the need for the development of very rapid computing technologies to help us see through the enormous amounts of data that we can generate now, and to see if it means anything. I would say 10 years ago, if I proposed a project where I said, well, let's sequence some people's whole genomes, and you'd go out and you'd say, where do I get $2 million to do that? Well, today You can do that for about 250 bucks. The technology's advanced so far. So with that kind of charge, the amount of data that gets generated is enormous. Then how do you plow through this as a person with an Excel spreadsheet? You need more, and AI is one way to do it, and has to be done properly, but it's going to come, and it's going to help us get some insights that we can then test. Go back and say, if we put this in an animal model, what will happen? And how does that change things? And then how does that mean we can develop a therapy, a treatment that would do something that changes that radically so that these people are better? So that's really what this was all about this morning, is an introduction to that whole area. It's very complicated.